What I really wanted to bring today was a bit more of what the practical applications of that work that all of you do is. And you know, I come from it from a fairly lay person's point of view. I'm not an academic in this area. I have a science background, I have a chemistry degree, but that's about it. And that's why I take the lead for Standard Gas on generally this sort of stuff. I do the carbon accounting. And ultimately, what are we, Standard Gas? I mean, I can rattle through some of the things here, but we process waste, okay? We've had a prototype going for 2 years. That's what it looked like. That gives you a sense of the scale. It deals with 50,000 tons of waste a year when it's up and running. And that is, if you think about what waste it can take, municipal solid waste is generally what it's designed for. It can take a wide range from fully fossil wastes like tire crumb, waste oil, so what comes out of the sump in your car when you go for a service, all the way down to just straight biogenic waste like forestry waste. The brilliant thing about this process is we've managed to find a way to cope with that very varied feedstock and the varied calorific values within that feedstock. And ultimately what we end up doing is producing 3 things. So we produce a syngas, which is a rich gas mainly of carbon monoxide, methane, carbon dioxide, and hydrogen, which is obviously what fractions you get depends on what you put in the front end. And then you get a char. And normally what you get with a pyrolysis, a fast pyrolysis process is some sort of liquid fraction, but we take the syngas and we pass it through a cracking process, much like a petrochemicals cracking process at 1100 degrees C. And that cracks all those long chain hydrocarbons down to methane. We get some ethene and ethylene and things like that, but generally down to single carbon molecules and hydrogen and carbon dioxide. And then it is cleaned by a dousing process that takes out all your chlorides and everything else that you don't want in there. So we're generally left with a very clean gas, which can either be burnt to produce electricity or can be further purified through other chemical processes. And then I think what's more interesting for this talk is you end up with a char. Now, if you put, obviously depending on what you put at the front end, depends on what your char is. We are not experts at the process of the exact chemical analysis of that char. In fact, we're at the process now, we're at the point now of the company where we are finding that the real answers that we need for the regulatory environment, for our investors, for everyone in this sector is what can you do with that char? So if you put forestry waste in, there's quite a lot of documented papers on what you can do with the char, what limits there are. There's a lot of regulation around what you have to do to it before you can put it on soil. But for char from municipal solid waste, there's very little. And in fact, obviously you can't put it on soil because it has heavy metals in it and various other impurities. But there's not much work done on what percentage of volatiles matter that char has with it. There's not a lot of work done on what you can, how you can sequester that for a long period of time. There's quite a bank of work done on putting it as an aggregate into bitumen and into concrete. But again, that's not fully developed to the point where we as a company can turn up and say to the concrete makers of this country or the Hansons of this world, you know, here is our char, here's the documentation on what you can do with it, and everyone's happy. We're not there yet. I think that's work that the sort of academics need to do, and that the industry needs to better understand to be confident that this is a good route for waste. So ultimately, you know, what what the first stumbling block we have is it char or is it biochar? There is this, if you think of where the word biochar came from, it is almost a niche word for char from 100% plant origin. And the problem we have is that we're running up against an issue here where biochar was for a previous market. So biochar existed almost to describe what you get when you or when you pyrolyze woody matter, plant matter. And now the world is looking at carbon removal. And so what all the things that mattered in producing a soil enhancer and in producing something that is suitable for from plants doesn't match what might be the best way of getting as much carbon dioxide out of the air and into a solid format that's stable and can be sequestered into concrete or even into landfill or mines or you know, anywhere where it has a permanence. So what this talk somewhat is about is how we cross that bridge and what the economics of that are, and trying to convince people that actually this is a good route for waste. So if you look at what the actual amount of carbon you can extract from municipal waste, there's about 10 million tons a year of municipal solid waste that goes to incineration, and of course that just gets oxidized and produces, well, if it's 10 million tons of waste, there's about 4 million tons of carbon in that. And obviously, once that goes to carbon dioxide, it weighs 3.67 times as much. So that's the amount that's emitted. And although incineration gives a good game in terms of talking about the capture of the energy, they generate electricity, and that replaces coal-fired power stations, they're really not very green. They belch out carbon dioxide because they oxidize all our waste. And although that is seen as better than landfill, because when you landfill things, even if you can capture a lot of that landfill gas, some of it will always become methane and get out into the atmosphere. Incineration says obviously it doesn't do that, and that's why to a certain extent landfill has been banned and the world has moved, or the Western world has moved to incineration. Incineration is still not the answer. It still doesn't stop emissions from waste. So waste is a huge problem we have where we feel that we can make a big effort. But again, as I said, and as I keep stressing, the char from municipal solid waste doesn't have a natural pathway at the moment. And the problem that we have with that is that the economics of char are the wrong way. So if you look at the price that anyone, like an incinerator or standard gas, gets for waste, the more fossil in that waste, the more we get paid to take it as a gate fee. And that obviously is the wrong way for the world in a way. We want to be encouraging the world to generate, if we're going to generate waste, to generate biogenic waste, not fossil waste. We'd like fossil waste to be eradicated, but as a result, from not really wanting, not liking fossil waste, it has an enormous fee associated with getting rid of it. So that inverts the usual economic drivers that you have in a market, in that people who deal with waste, so incinerators, not landfill, but people such as ourselves, we get paid more to take fossil waste. So although I haven't labeled this diagram particularly well, if you look at some of the markers on that, if we look at the 130, you get paid £130 a ton to take waste oil from the sumps of cars. You get paid £95 a ton to take high plastic, non-recyclable plastic waste. So that's like even medical waste, so low grade, non-biohazard medical waste. So all your plastic that's come from PPE, that would be in there. If it's non-soiled, that would grant you about £90, £100 a ton. And the other thing about having high fossil feedstock is that it's very, very calorific. Obviously, it being mainly hydrocarbon based, it's carbon and hydrogen, it has enormous calorific properties. So it's 1.4 times as calorific as just normal municipal waste, which is a mix of plastic and biogenic feedstocks. So by the time you get to what would be a more classic biogenic waste, where you've got 50-50, you're here. So you get paid £85 a tonne for 50-50 biogenic fossil waste. That's what's called RDF. That's packaged black bin bag waste. So it's had all the, quite a lot of the moisture taken out of it. It's been through a MRF where it's been sorted and the metals have been taken out, the big bits of crockery, and you're left with just what used to go to landfill, what would go to incineration. You get paid quite a lot of that because it's very unhomogeneous. It's very heterogeneous, should I say. It's very, you don't know quite what it is. It varies in terms of what time of year it is. It varies depending on where you are. So there's quite a high value of it because generally you need the alternative to that is it goes to landfill and it has to pay a landfill tax of £93 a tonne. So that's why it's priced at about 85. But everything else, there is this loose relationship between waste having a low biogenic content and not being worth very much. So if you go to forestry waste, you don't get anything for forestry waste. People want forestry waste. Why? Because you can produce a biochar from it, and biochar has a value. And so that's how that market works. But the general gist of what I think you should remember here is for every, roughly, that if you look at the line, for every £1 you spend less on your gate fee, you get 1%.
Just a one-off problem, or
Say again? No mind, I'll carry on. So for every, let's assume that for 100% fossil you get paid £100. For 0% fossil you get paid £0. That's not a rough. That's quite a good guide as to what the economics of char and biochar for the waste sector, at least. Now, why is this imperfection there? Well, I touched why you get an imperfection on biochar. Whenever there's an imperfection in a market, or it doesn't seem to follow any sense, because the world wants to remove carbon dioxide, and to remove carbon dioxide, you want to encourage the market to take a higher biogenic waste. The reason it's the other way around is one, the market for carbon removal isn't big enough yet to impact the waste market. There's far more waste to be dealt with. And so that market is driven by how much waste there is to get dealt with, than the market cares about carbon removal at the moment. So although there's an awful lot of noise about carbon removal, it's not driving this market at all. So £100 a tonne for pure carbon removal certificate. So if you put a tonne of carbon into the ground that was once biogenic atmospheric carbon dioxide, or what should I say, a tonne of carbon dioxide equivalent, if you sequester that into the ground, you could get between 100 and 150 pounds a tonne for that. But you're giving up way more than that if you're a waste processor, because you got zero for that feedstock, and you could have got £85 a tonne for RDF. And although you'll yield a lot less suitable carbon for sequestration, you'll get paid a lot more to take the waste. So that tells us that the market for waste is what's driving all these prices at the moment. It's not the market for the products of waste. It's not the carbon that's driving it. It's just the sheer tonnage of waste that needs to get rid of. And then again, there's the added problem of plastic. No one wants plastic waste around. So there is a onus to get rid of it. And the onus to get rid of it means that people will be seen to pay a lot of money to send it to incineration. So given that there's nothing else that can be done with plastic, the last thing we want is to see it out in the environment. And the last thing it does seem that people want is for it to be filling landfills where it doesn't degrade at all. And it slowly, so the argument goes, leaks out into the environment. People will pay a lot of money to have it burned. But the problem with that obviously is it just leads to enormous emissions from the incinerators. So what is the future? Why is there something on the horizon that could solve this? Well, obviously demand for carbon removal is growing. And the more that we demand carbon removal, the more that we show how we can take biogenic feedstocks, put them into a process where we extract get char from them, and then we sequester that char safely into the ground, and people pay just for the process of sequestering it into the ground, the more we turn this waste market on its head, and we tell people that you need to really, really drive a price differential between fossil waste and biogenic waste, because obviously you won't get that carbon credit for fossil waste. So what does that do? Well, that steepens the curve that I was talking about here. It means that you have to pay more and more for fossil waste because you get so little the other side. So the more we put the price of carbon up, the more we rotate this this line clockwise, the steeper it gets. Okay, and what will actually happen is you'll end up, people will obviously pay more and more for biogenic waste because the whole world is demanding biogenic waste because you can generate a carbon credit from it. Now, why does that have an impact beyond the waste market? Well, obviously it has a big impact for the proponents of BECCS and anything that uses a biogenic feedstock to produce a solid char, or even if they're using a wood chip to power stations and they're hoping of capturing the flue gas and sequestering it in the North Sea. Because the problem that will that have is as we demand more and more biogenic only feedstock, then obviously the price of it goes up, and the price of it going up means it goes more negative on this chart. So the future really, where's this all going in the future? What we're going to see is we're going to see a massive widening of the price for taking on fossil waste versus biochar versus biogenic waste. And the way that you are going to see that is the more and more we find a way of getting an economic reward for sequestering char from municipal waste. The more we understand that process, the more we convince regulators, corporates, and all the people who are involved in this market, the more we can sequester that what is a mixed char, basically, because it's 40% of municipal waste is biogenic, 40% is fossil, and so your char, you can't separate the char. Obviously, you end up with a mismatch of everything. The more that we prove that is safe to put into aggregates, the more you get this driving of the market, and the more you'll get an overpricing of how much it costs to get rid of fossil waste. Now, what does that mean for the world? It means the world is not going to want to put stuff in fossil packaging. It means the world is not going to want to produce plastics that cannot be recycled, because the cost of getting rid of that at the end of use becomes prohibitive. You know, I could very easily see the cost of getting rid of a ton of plastic reaching £250 very, very quickly over the next 5 years, as the price driven by the price of carbon removal credits. So, you know, where does that get us really in terms of where companies are going and the economics of all this? I mean, I've borrowed this diagram from a good old phase diagram of water, but basically it could work another way. You know, you've got companies that live in this world where the price of carbon is going up and up and up, and that suits them. Okay, that will drive new. So in the waste sector, to a certain extent, that's good for the waste sector. Whether it's us who do a clean, economic and carbon negative removal or processing of waste, or even incineration. If incineration, all it means, if there's no alternative to incineration, it just means the more the price of carbon goes up, the more they'll get paid to take the waste on. So it will be fine for them. Obviously, the old economy companies, the oil companies, companies who are heavy energy users, they're traveling down this problem. They make less and less profit as the price of carbon goes up, and then they have a decision to make at the triple point, which is, do they go bust, or do they adjust and find new routes and adapt to new routes in this economy? So I think it is a very exciting time for the world to see all these companies traveling somewhere along these lines. And I think the market is very, very rapidly deciding what happens to your company at this point here. And if your company is blatantly on this line here, you're starting to get a real kicker to the value of your company. And I think, as academics, as just people who are perhaps not coming at this from a market perspective, I think you'll see more and more of this, and you're really starting to see this in the valuation of corporates and how people present themselves. And just one last thing, because we're running out of time now, this is a good schematic on how on earth this new economy of dealing with waste can be beneficial to the whole world, and why it's not just one of those sort of tricks where we say we're brilliant, but what we actually mean is we're just an improvement on something that's very dirty. And that's not the case. These are our carbon numbers on our sorted waste. So this is where I hope the waste market gets to very, very quickly, where it takes quite a lot of plastic out of municipal solid waste, more than is the case at the moment. So what we've done here is we've got a partner who provides us with waste where normally your RDF that comes out of black bin bags after it's been sorted has got 50-50 biogenic and fossil in, but there is another process you can go through, which is a bit more, intensive, where you pick all the little bits of plastic out, even if they're non-recyclable, just because from a carbon perspective, you don't want to process that fossil carbon. And you get something which is a little richer. This scenario here is 90% biogenic, which is what we're told you can get after you spend £20 a ton sorting the plastics out of your waste. And you can see here that running that sort of waste through our process, every single ton this is for 100 tons of carbon of feedstock, you get almost the same amount removed from the atmosphere through running this process, because not only are you extracting some of it as char and sequestering it forever, but obviously you've got a very biogenic feedstock, and that biogenic feedstock has been produced from sucking carbon dioxide out of the air. So there is hope on the horizon that just a small shift in the waste market, a small move to sorting more plastics out, to focusing a little more on what it means for the carbon removal of the process, the whole waste sector of the UK and what is in waste and the amount of emissions coming from waste will turn on a sixpence and go from very polluting, which it is at the moment, to being actually a contributor towards solving the problem, and actually a pathway to taking carbon dioxide out of the atmosphere and putting it into the ground. But as I said before, in summary, what we actually need is a lot more academic work to help understand this process here, the process of getting solid matter into the ground safely and understanding how stable it is, what is the most stable way we can get it stored, and what the permanence around that is. So I'll end there. I'm sure there are questions. Christian, if you want to jump in, please go ahead.
Yes, thank you, Richard, for your presentation. That was a lot of information on how the waste market works. Sorry. So you got a couple of questions. I will just ask them directly. So Don asked them, so based on your economics, is fast pyrolysis unsuitable for producing biochar for carbon sequestration?
Yes. So the differential is, the best thing to think about is you take in 50,000 tons of waste a year for one unit, and you produce about 15,000 tons of carbon removal credits that you might be eligible for. So call it a 3-to-1 ratio. So you care 3 times as much what you get paid for your waste than you care what the cost of carbon removal is. And you roughly get the same energy out of them. You roughly get the same electricity. You know, all your products, all your revenue streams are otherwise the same. So we would need the price of carbon to go from 100 to 300 to compensate us from going from you know, a normal feedstock to 100% plant-based feedstock that you don't get paid for. So it's a 3-to-1 ratio roughly on the price of carbon to our feedstock.
So as a follow-up question there, what would you expect this will be the development of the carbon price? Because we see a lot of movement in the last two years maybe, or one.
Yeah, so I think that there's the official sort of ETS, European carbon price, you know, which is for the energy sector really. I mean that's just started to trade over 50 euros a ton, but I think that's a well-managed market where in fact it's very political and there are quite a few carve-outs. So I don't think that's driven. That's almost driven by what governments, the amount of governments want to put pressure on energy providers to clean up their act. And it is somewhat, and I don't want to sound too skeptical here, but it is somewhat a managed market by the politicians and you know, by the aims. And who knows, but if Germany votes in a green government, I think that could go up quite considerably. And that's why we're starting to see the rise already as the market prices that in and realizes that the drive for is going to get more, it's going to get harder, you know, to run your coal-fired power stations in Poland, for instance. And so the price is reacting to that. I think what's more interesting is what corporates, so the you know, the Googles, the Facebooks, the Microsofts of this world want to pay for carbon. And I think very quickly they're starting to pay more than the £2 they can get away with an offset credit at the moment. What's really interesting is they're really starting to pay a lot of focus on what the story is. Are you really doing carbon removal, for instance? And there's a lot of stress on the science and understanding the exact story of your carbon removal, as it were. And so all these, like, there's a RED Plus which is to do with forestry replacement. You know, that's losing a lot of favor at the moment, because in the past people would buy a lot of RED Plus credits because they can get their hands on them. And if you're a big corporate and you need to offset 500,000 tons of carbon dioxide a year, you can buy 500,000 tons of RED Plus credits and it's job done, and you put it in your annual report and you feel fine for that year. I think people now are saying, well, that's not a good enough story. We want a better story. We want a more positive story. We want to make, you know, we want to be more insulated from people saying that we pollute as a company. And so we want a story that stands up to scrutiny and that is more, is more scientifically based. And as a result, then the price starts shooting up because the number of viable companies that do real removal is very small, very small. And so the price there is around 100 to 120 pounds a ton, dollars a ton, sorry. But it's only going to go up because the demand way outstrips the supply at the moment.
Then the last question from Pravin, because we are quite
sure
on time. What do you think is the cross market of waste plastic conversion in the future?
Yeah, so I'm very positive on that. It's not something that we would benefit from. What I would like to see is plastic conversion. So the Quantafuels of this world, there's another company called Recycling Technologies that does some good work in that sector. But they're not, you know, they're not waste processors. They need a specific type of plastic, and they're really expanding what I would say is the recycling world. So they're taking and broadening the type of plastics that you could recycle. I think there is a lot. It's not easy, obviously. You know, chemically, I think it's a very difficult thing to do, and I think. I'm not an industrial chemist, but there are obvious limits to how many times you can do it in one cycle without the molecules degrading and basically it not being possible anymore. So you have wastage, and quite considerable wastage in that. It's not a closed cycle. It's quite a wasteful cycle, but still, I think it's only good news that those technologies are developing. There is money going into them. And some people are very close to being economically viable doing it. And you know what we're talking about there is producing builder molecules, basically starter molecules, which can then go back into the process and start their life again. And they never enter the waste stream. They're never really a waste. They're a feeder molecule. But the good story for us for that, as that develops, is this. It makes the biogenic content of waste much higher. You know, my dream for where we get to within a very short space of time is that eventually there's very little fossil in waste, you know, because once we get to that point, we don't have to worry about the emissions per se. We just need to make sure that at least we're producing some solid matter from the waste, and that we can store that. And then, you know, that's when the whole waste sector becomes a benefit to the world's attempts to get to net zero, rather than making it worse, which is the case at the moment.
It's a nice finishing sentence. So if anyone has a really good idea for RDF biochar applications, I think you can write to Richard. And thank you very much, Richard, for your
Thank you very much.
nice input.
Brilliant.
And